Welcome back to Code Meets World. Today we're looking at LeetCode problem 2013, Detect Squares. So here we're given a stream of points on the XY plane, and we need to design an algorithm that can add new points to the stream, add new points from the stream into a data structure. Duplicate points are allowed and should be treated as different points. And then so that's one thing we need to be able to do. The second thing is, given a query point, we have to count the number of ways to choose 3 points from the data structure such that the 3 points and the query point form an axis-aligned square with positive area. An axis-aligned square is a square whose edges are all the same length, like a normal square, and are either parallel or perpendicular to the x or y axis. So we need to implement, as you can see in the code, a couple of different functions. So we need to initialize, then we need to have something to add, and something to count. And then we're given an example. And I've opened this example in a new tab so we can actually look at what this is doing and talk about it. Because this problem is a bit involved. So we are given 3 points to add to our XY plane, as you can see here. So, and these are called in a stream. So one after another sequentially. So first we add the point 310, which is in blue. Then we add the point 11.2, which is in purple. And then we add the point 3.2, which is in green. So our data structure, whatever we decide to use, now has these 3 points in it. Then, if a call to the count function is made with this additional point, this is called the query point, according to the problem write-up. This query point they're marking with an orange square, so it's not actually in the data structure, but it's a query point. And the question we're asking is, using this query point, how many squares can we form using points that are in the data structure plus this query point? So in this case, because we have these 3, and then we add in this query point, we can make a full 1 square like this. So we would return 1 as the solution to this call to count. Now for a second, let's just talk about what axis-aligned square means. This means that all the sides have to be the same length, but it also means that all the sides of the square must be parallel to either the x or y axis. So if this square was actually rotated, so it was like a diamond, that would not be allowed. It has to have all sides parallel to the x and y axis. And it can't be negative, because it said it has to have a positive area. So we don't have to worry about any negative numbers either. Okay, so continuing with the example. Next, and when this is important, when we check with a query point, that point does not get added to the data structure. So you can see on the next call, we have a different query point, which is over here at 14.8. We don't keep this orange square from the first call. That's just a query point. We don't save it. So when we make the call with 14.8, we would return 0 here because it's not possible to make a square with the given values. Then if we add 11.2, and this is the duplicates part of the problem, we now have 2 points that are the exact same. And you might ask, why does this matter? Well, because if we then call count with 11.10, again, just like we did up here, we now have to return 2 instead of 1, because you can make a square with the purple point, but you can also make a square with the red point. So that's why we have to handle duplicates. So that was a lot. There's a lot going on with this problem. Let's talk on the whiteboard about how we might go about solving this, because there's a lot of things to consider here. The first thing I want to talk about is what data structure that we're going to use to store all of these values. Because it's a graph, I really like the idea of using a 2-dimensional array so that we can store every single point that we have. So for instance, if we had a 2D array, we could store, for instance, if we have a value at 0, if we have a point at 0, 0, we can mark that as true. If we have a point at 0, 2, we can mark that as true. And if it's marked as false, there's no point there. So that's something that we could do. And this would just have to be the problem. I didn't show this on the last screen, but the problem statement says that x and y can be between 0 and 1,000. So this would have to be basically 999 if it starts at 0. This two-dimensional array, to store every single point, would have to be really long. And we could do that, but I think it's going to be a really slow solution, because to look for a point in a certain row, we would have to iterate over all of these 999 rows. And that would take a long time, and this array would be very sparse. And sparse means there are a lot more empty values than filled values. So for instance, we have this huge 1000 by 1000 array, but there might be only 10 true values and the rest are all false. And so it's going to take a long time to search for the true values, which seems really slow. So that's one option, a 2D array. That's definitely one option. But what I'm thinking of is a data structure that might grow as we add points, but isn't taking up unnecessary time and space by being a huge 2D array off the bat. And so what I'm thinking is to use a dictionary, and maybe even a dictionary of dictionaries. So what if we had an initial dictionary, and the key was the x value of a point. So for instance, say we had the point 3, 2, and I wanted to store that. What I could do is, in this dictionary, the key would be the x value of my point down here, so 3. The value associated with that key would be another dictionary, and that dictionary would be filled with all of the y values associated with that point, so 2, and then the value associated with this would be the number of times we've seen that point. So because we could have duplicate points. So this would be the count for how many times we've seen that point. So I'll just put 1. So let me talk about what I just did there. I have a dictionary, and the first thing I look up is the x value of my point. So I look up the x value of the point, and I see that it's in the dictionary. So I go ahead and I grab the value associated with it, which is another dictionary, and this gives me all of the points that have the x value 3. In this case, there's just 1, which is the y value of 2, and we've seen that 1 time. So then if I added another point to the dictionary in this way, for instance, I could add 1, 1, and maybe I have 2 of those. Maybe I've seen the point 1, 1 twice. In that case, I would have to add another dictionary entry, which is 1, and that dictionary would have in it a 1, and then I've seen that twice, like that. So hopefully that makes sense. And the reason I prefer this to the solution we talked about over here is because this solution on the right only stores as many points as we have. It does not build a giant array for points that we may never use. And the other nice thing about this method is when I talk about how I'm going to find the squares, I think it's really important that we can say, hey, I want to look for every point in this row or in this column, and I can find that right away. So for instance, I can find every point that has an x value of 3 immediately, because this would just be a list or a dictionary of all the points that are in a certain row. So now we need to talk about how to actually solve this problem. So think about it this way. Instead of keeping track of all the points in the XY plane, I'm gonna keep track of them sort of in a rotated way so that I can think about it like it's a matrix. So the point 0, 0 is up here instead of down here. That doesn't matter because a square down here, if we rotate the axis 90 degrees, it's still going to be a square in this view of it. So I'm going to think about all of the values like this. What we have to check, and there's a few different ways we could do this, but we just have to check using the green point, can we make a square using everything that's in white? Obviously you can see that we can, but how can we tell our code to do that? What I'm thinking we do is first take the green point, which we're given. That's the query point, so that's 0, 2. Take the query point, look at the x value, which is 0, and find every other point that's in the same row. So every other point that's in the row with x point 0. And remember, using our data structure, we'll be able to do that immediately because we'll look in the first dictionary and we'll look up the x value 0, and then we'll get all the points that are in that row. So that's why I'm using the data structure in that way. So we look up 0, and we get all the points that have a 0 as the x value. So in this case, we would get 0, 0. So now we have 2 points, 0, 2, and 0, 0. They're in the same row, so we know that they are axis aligned so far because they're parallel with the x-axis. So then what I would do next is calculate the length of the side. So this value here, and we can just call that length. And we would get that by doing 2 minus 0, which equals 2. And that's just using the y values. So now we know the length of the side that we're looking for, and we have our 2 points. So what we have to do to check if there are any squares that we can make is simply take our point that we found, which is 0, 0, and look below it and look above it, right? Because the two ways that we could have a square are if there are points, and we could draw it in red again, if there are points length away down or length away up. Now, obviously, length away up is going off the end of the grid, so that's not going to work here, so we don't have to consider that one. But we have to check below the point, the distance length, and then we can do the same thing over here. And we can go from our green point and go length down. And then if we have a point in those two locations, so going length down from our 2 points, if there are points in both of those spots in our data structure, then we can add 1 to the number of squares that we can make. Now, if we weren't so close to the top of the axis here, and say there could be other points up here, and drawing the length actually worked and there were points there, then we would return 2, because we could make 2 different squares using our point. So that's the general method I'm going to use. I'm going to take the query point, I'm going to find every single other point in the same row. So we take our query point, we find every other value in the same row, and for every one of those values, we check, is there points below each of them that are the same length as the distance between the 2 points here? And that would form a square, and so we would add 1 to our solution. And now there could be a lot of points in this row, and we have to do this process for every single one of those points and add up the number of squares we find for all of them. The final point to this is, why did I save in the data structure the number of occurrences we see of each point? And that's because when I make a square, I can then use the counts to figure out how many squares are made at each spot. So for instance, if the query point is obviously just one, say there's just one of these, there's also one of these, but maybe there's 2 points down here. If that's the case, then one cool trick I can do is say 1 times 1 times 1 times 2, which equals 2. And that's how many different squares I can make with that combination. If, for instance, there were 3 points here and 2 points here, then I could do 1 times 1 times 3 times 2, which equals 6. There are 6 squares that I could make there. And so that's the reason I'm storing the count, so that I could do this math at the end to figure out how many unique squares we can make. So with all of that, let's go to the actual code and see if we can write this solution. Okay, so we're back at the code now, and the first thing we're going to do is, according to the instructions, we need to initialize an empty data structure for our solution. And so like I talked about, I'm going to use a dictionary of dictionaries, and I will just call it self.data. And at the beginning, I just need to set that equal to an empty dictionary. And then I'll go about the process of creating dictionaries inside of that dictionary in the next function, which is add. So what I'll start out by doing first is actually extracting our x and y values. So x is just going to be 0.0, y is going to be 0.1. And so this is a point that we need to add to the data structure. So this isn't a query point to find the square. We're just adding this to our data structure. So what I can do first is I can say if x is not in self.data, so meaning we're seeing a point that's in a brand new row. We've never seen this point, or we've never seen a point in this row before. If that's the case, then x is not going to be in the dictionary. And back on the whiteboard, that means there is no entry for x in this original dictionary. So the first thing we need to do is add it. So we can say self.data x, and this is where I create the inner dictionary. So if I go into self.data, which is a dictionary, and I look up the value x, I'm going to get another dictionary in return, which is where we're going to put all the y values. So we can say under here, if x is not in it, that means we've also never seen the associated y value. So in that case, we can say self.data x, y. So this is go into the original dictionary, look up x, which is going to give us that inner dictionary, and inside of that dictionary, look up y, which will give us the count for how many times we've seen the xy point. And because this is the first time we're seeing all of this, the count is going to be 1. Now, there's another case here, right, which is x was in the original self.data, meaning we've already seen a point in that row before. If that is the case, the first thing we need to ask ourselves is if y not in self.data x. So meaning self.data x exists, so we've seen points in this row before, but if we've never seen point x, y, then we just need to do the same thing that we did here. So we just need to say self.data x, y equals 1. Otherwise, meaning x is already in the original dictionary, and y is also already in the inner dictionary, meaning we've already seen point xy before, then we just need to increment it by saying self.data xy plus equals 1, meaning we've seen this point before, so we need to add 1 because we're seeing it again. It's a duplicate point. Okay, so now we need to work on the count function, which is where I'm going to delete this stuff down here. The count function is where all the interesting stuff is going to happen. So everything that I talked about in this picture here. So what we need to do first is initialize our solution, which is going to be set to 0, and we will add, every time we find a square that matches the criteria, we'll add it to the solution. And then just to make this a bit easier, I think I will define x is 0.0. So in this case, point up here, point was what we were adding to our data structure. Down here, point is the query point. So point is the x, or the orange square in the original example that we looked at. So this is a point that's not in the data structure. So the first thing we can check is if x is in self.data, because if x is not in self.data, what that means is if there are no points in the same row is the query point. If that's the case, it's going to be impossible to make the square, any of the squares, so we can just immediately stop. And outside this while loop, we are going to return solution. So if x is not in self.data, we won't even go into the loop, into the if statement, and we'll just return 0 because it's impossible to make a square in that case. If x is in self.data, then we need to loop through all of the points in that row. So the way we can do that, because we have a dictionary, is we can say for y, we'll call it count, in self.data x, so this is the row, self.data x will give us the whole row. And then dot items is a convenient thing we can do in Python for a dictionary. So this is going to give us each entry in the inner dictionary. So we'll get the y value, which is this, and then we'll also get the count, which is the second value. If we have a point that's any points that are the same as the query points, I think we want to ignore. So we can say if y does not equal 0.1, like that. And this means any of the values that are exactly the same as the query point, we're not going to use those to form a square, because the square, this makes more sense. The square would be length 0 in that case, right? Because the distance between point x, the distance between point x and that white dot, they're on the same point, so the distance between them is 0. And the problem said that they need to have positive area. So that's impossible. So we will skip any of the points that are the same as the queried point. So now we need to do the two things that we talked about on the whiteboard, which was we need to check the points below our two values, and we need to check the points above them and see if there are any squares that fit those criteria. So basically what I'm gonna say is case 1, which are points are above, and then case number 2, which is that points are below. And what I'll do first is I will say, well, first what I can do is I can calculate the side length, which is shown in red on the whiteboard. And side length is, I can do y minus 0.1, like that. And I think I need to take the absolute value of that, like this. And this is going to work no matter which point is on the right. So if I get a negative number, we'll just make the positive. And so that's just finding the distance between these 2 points right here. So the query point and then any point that's in the same row is it, which is what we're looping over here. So we'll get the length. And then the first thing I want to check is, are these points above it? And so I need to figure out which row I need to check. So I'll call the offset above, and above is going to be equal to x. So x is the row that we're in right now. And to go up in an array, if we're thinking about it like this, we need to subtract from that the side length. So this is going to give me the row I need to check for the points. So once I have that, what I can do is say if above is in self.data, meaning have I seen any points in that row? And in our case here, this would return false because there are not any rows outside of this matrix. But if we were farther down and then we could go up, we would check, have we seen any points in this row? Because if we haven't seen any points in this row, we don't need to check for squares because it's not possible. But if there are points in that row, we're going to be able to increment solution based on how many squares we find. So we need to check a fictitious point up here and a point up here. And if they're both there, we need, like I showed down here, we need to multiply the number of times we've seen this point, times this point, times this point, times this point, and that'll give us how many unique squares we can make. So this is where it's going to get a little bit tricky to put this all together. The first thing we need to multiply together, we technically don't have to ever multiply the query points count because that'll always be 1. There's just one of those. So the first thing we need to do is multiply the count of how many times we've seen this point. Well, we have that for free. That's the count value. So we can say count. Now we need to multiply that. So now we have this one and this one accounted for. So now we have to account for a point that's up here, the correct length away from the point that we started at. So for this, we just need to go into the data structure and see if that point exists, and if it does, get the count of how many times we've seen it. So the way we can do this is we can say self.data, and instead of using this notation, I'm going to use the get notation. And the reason that I do that will be apparent in a second, because if the value is not in the dictionary, I don't want to return none, which is what usually happens. I want to return 0, right? Because if any of the counts return 0, solution will get incremented by 0, meaning we didn't see any squares. If I returned none, I'd get some sort of error because I'm multiplying numbers times none. So I need to use get. So this is getting the row that's above these points. And then we will get the y value. And this is where the get function is helpful, because if I say get y0, this will check that y is in the dictionary. And if it is, it'll return the count. But if it's not in the dictionary, it'll return 0. So now we have the count. Well, we already have this one accounted for because it's always 1. This is represented by count. And now we got the value up here. So we're just missing one value, which is the top right one. To get that one, we can say self.data.get. Again, we'll say above .get, but this time instead of getting the value that's in column y, we'll get the value that's in column 0.1, which is above the query point. And again, we'll say 0 here, meaning return 0 if it's not in the dictionary. So that's how we handle case 1. Case 2 is going to be exactly the same, so much so that I'm just going to copy this and change this to below. Again, if we have a row and we need to go down, in the array, we need to add to the rows. So that's why I changed below to plus. And then we again check if there are any points in that row. If there are, then we can go down to that row and get the y value there. Again, returning 0 if it's not there. And same thing, we go down to get the points. Again, this time under the query point, return 0 if it's not there. And all of this gets returned as solution at the end. That was a lot. So let's go ahead and run this. And we are seeing that that is working. And the test cases are kind of interesting here. So when it says detect squares, just returns in null. And when it adds, it just returns null. But when it makes a call to count, then you return the actual solution. So that's just how it's grading it there. And now we'll go ahead and submit this. And there we go. We hit the 97th percentile solution here and 92nd percentile for memory. And I think the reason this is so fast is because, like I showed on the whiteboard, I could have done this as a 2D array, and it might have been a little bit simpler to explain in that case. But again, when we had to check every row, we might have been looping over 1,000 values just to find one true, which is really slow if you do this a lot. But in my solution, we only have values stored if they are in the graph. So it's a lot faster to look up all of the points. And I think that's why we have such a good runtime here. So yeah, hope you enjoyed, and I'll see you in the next video.